Welcome to another video. Now let's pause the video and give this a try. Okay, now let's check this. We have 3 exponent 2x on the root sign here plus x equals to 59,059. Now the only problem here is the square root sign here. Okay, now when you have a square root of x is the same as x to the power half. So from here I can say that 3 to the power 2x times half, okay, when following this rule, plus x equals to 59059. Now we can do cancellation, whereby this one will be 3 to the power x plus x equals to 59059. Okay, now let's pause the video and then solve this by inspection. Now if I plug in 10 to the power 10 plus x, that is 10, I'll get this. So x is 10. So how do you solve for that 10? That's the problem. So let's see how the solution will be. Now let's send the x to the right hand side. So that will be 3 to the power x equals 59059 minus x. Now let's divide both sides by 3 to the power x. 3 to the power x, we are sending everything to the right hand side. So this side will go. So I have 1 equals to 59059 minus x on 3 to the power x. We can write this one as 59059 minus x times 3 to the power minus x. Okay, now we want to apply the Lambert W function here. And when we have W function of p times e to the power p, the answer is p. So what is here must be equal to what is here. So look, we have this. We want to make this side equals this. So we are going to, add 3 to the power 59059 to both sides. So we have 3 to the power 59059 minus x times 3 to the power 59059. Okay, all right. So we have 59059 equals to 59059 minus x. Now let's apply indices. Let's add the powers. That will be 3 to the power 59059 minus x. So that's that. Now from here, since W function of alpha e raised alpha is called alpha, let's introduce the e here. Okay, So we have 59059 minus x. So this side will be raised to ln of 359059 minus x. That's the case. So this side will be 359059. Let me repeat the same thing here. Now from here we can write this one as a pi rule. So we have 59059 minus x. So that will be e. So this one is a pi rule. So it will be 59059 minus x ln of 3. And we have this side as that. Okay, so we are still working towards this one. So this side must be equal to this side, but ln of 3 is missing. So we are going to multiply both sides by that. So that will be ln of 3 times 3 to the power 59059 equals to 590 minus x times ln of 3. We have v 59059 minus x ln of 3. Perfect. So from here we can take the... Okay, so from here I'll have 59059 minus x times ln of 3. Now let's adjust this so that we get something like alpha e raised to alpha. Okay, all right, now we can say that ln of 3 times, so we want to write this one as 3 to the power 59049 times 3 to the power 10. Now if I perform this here, this side will still be 59059. So I've done nothing. Now I want to write this side as w function of 3 to the power 10 ln of 3. So we have this one here times 3 to the power 59049, okay, equals to 59059 minus x ln of 3. Now 3 to the power 10 is this 59049, okay, equals to 59059 minus x ln of 3. Okay, now since we are working towards this, let's introduce e here. So this side will be w function of 59049 ln of 3 have e raised to 3 to the power 49 59059 minus x, and write it well, ln of 3. Okay, so work this one. It's a power e raised to box exponent t. So this t will occupy this position. So that will be w function of 59049 ln of 3 times c 59049 ln of 3 equals to 59059 minus x ln of 3. Okay, so work the left hand side carefully. So you can see that this one equals that. So taking w function of this will give us 59049 ln of 3 equals to 59059 minus x. Sorry, minus x ln of 3. Okay, so this one will cancel this. So I'll be left with 59049 equals to 59059 minus x. So it's the same as x equals to 59059 minus 59049. So which will be 59059 minus 59049. So the answer is 10. Okay, so x is 10. So my final answer is 10. Alright, so that is that.